teeth have complex and unique shapes. In prosthodontics, the ability to observe and analyze shape and how these shapes relate to each other is critically important. I'm Dr. Paula Flynn from the Department of Restorative Dentistry at the SUNY at Buffalo School of Dental Medicine. All objects have a shape. Shape refers to an object's flat, two-dimensional geometric configuration of height and width. We know this ball is a three-dimensional sphere, but its shape is a circle. Dental terms used to describe an object's shape include height of contour, undercut, infrabulge, suprabulge. As these dental terms are explained, it can help to remember the definitions of concavity, meaning curving in or hollowed inward, and convexity, meaning curving or bulging outward. The greatest bulge or convexity an object has with respect to its orientation to the vertical plane is known as its height of contour. To help identify the greatest bulge or height of contour, it helps to put a straight edge or ruler at the bulge or convexity and look for triangles of light that form above or below the contact with the straight edge. The degree of convexity and concavity can change if the position of the object is changed in relation to the vertical reference line. Undercut is the portion of a surface or an area of space below the height of contour. Undercut can be represented as a triangle with its point at the height of contour and its base on the horizontal plane. Undercut is also known as the infrabulge area or downward facing surface. The upward facing surface above the height of contour is known as suprabulge. These concepts can be observed in nature. We can observe the greatest bulge or convexity and its related concavity. Practical suggestions on the conscious observation of shape are found in Greg Albert's book, Drawing, You Can Do It. These include: look for the silhouette shape, the outer edge or outline form. Notice the negative shapes or spaces, shapes between and around things. Use a measuring device. Look for alignments. Notice how various parts or points line up or form geometric patterns. Think shapes as you observe: circles, angles, squares, triangles, and so on. Part of the plan for designing a prosthesis is identifying the path of insertion. This path is the movement of the prosthesis past the surfaces of the teeth to come to rest and be supported by the teeth. When considering the path of insertion for a dental prosthesis, the ability to identify slopes, convexities, and concavities is important. For both fixed and removable prosthodontics, the path must follow parallel or relatively parallel surfaces. Otherwise, the prosthesis will not seat. The contact points of the prosthesis and the teeth must fit together exactly, like puzzle pieces do. Think of multiple proximal surfaces as multiple architectural columns or multiple parallel surfaces. These parallel surfaces are incorporated into the final prosthesis, replicating the path of insertion we have chosen. Any rigid part of the prosthesis will have a final position below the height of contour, must slide past the height of contour, and will not contact tooth structure below the survey line. To help identify contact with a vertical reference to a surface and the amount of curvature at the contact area, look for triangles of light that are formed when the vertical surface contacts the tooth at the height of contour. There will be suprabulge and infrabulge triangles of light. With experience, we can train our eyes to analyze shape. A dental surveyor adds precision to the analysis.